So we're going to start with, before going into probabilities, we're going to start with the simple permutation combination on what that means and the rules of counting, as they call it. All right. So the best way for me to explain these would be through just simply doing like actual questions. And before even going into counting, we need to learn about the factorials and what a factorial is. All right. So a factorial is very simple. All that is that if you have a number, it is given by the exclamation mark that is after the number. This simply means it is equal to 5 times 4 times 3 times 2 times 1. So all the way up to 1. Okay? That is what a factorial simply is. The rules for factorials are very simple. Simplification of factorial is very simple. And you can use the calculator. It is also available there using the Shift and X power -1 button, which is under mode setup. That's where you can find the factorial button. One rule you need to know is 0 factorial is equal to 1. There is a lot of different proofs for why this is the case. All you guys need to do is just memorize that 0 factorial is equal to 1. And when you have division of factorials, you can cancel them out. So for example, if you have 10 factorial divided by 7 factorial, remember this is simply equal to 10 times 9 times 8 times 7 times 6 times 5, all right, all the way to 1. It's divided by, this is 7 times 6 times 5, all the way to 1. So when you have 10 factorial over 7 factorial, we can simply cancel out this entire part over here with this entire part because you're dividing by each other, so you can cancel them out. So in other words, we can say that 10 factorial over 7 factorial is simply equal to 10 times 9 times 8. All right? So this is another thing you should know when it comes to factorials. Let's start looking at the questions. These are the basic rules when it comes to factorials, and we will start solving as we go along. So part A was the one I just solved. Part B says 9 factorial times 5 factorial over 3 factorial, all right? So what can we do? We can just simplify all of this, and then we can simplify the 5 factorial, so it will be 9 factorial times 5 times 4 times 3 times 2 times 1 will cancel with the 3 factorial at the bottom. So put this in the calculator and you will get, it does say without using a calculator, but again, in the exam you have a calculator. This is just to explain the concept very easily. 47 factorial times 4 factorial over 48 factorial. Same idea. This is going to be 47 times 46 times 45. So at the bottom, we'll just remain with 48. And at the top, we will remain with 4 factorial. So it's 4 times 3 times 2 over 48. The reason behind this is the 47, it's 47 times 46 times 45. And at the bottom, we have 48 times 47 times 46 times 45, all the way to 1. So these will all cancel out together and we will remain with 48. I'm not going to take too much time with this. It's just the basic concept of how to solve for factorials. I'm also going to skip the second one. Actually, I'll do one question in the second one just in case it comes in the exam because it's using n. So the form of factorial, and then it gives you n plus 2 factorial over n factorial. Simplify this. What I would do is I would put a random number for n that is not equal to 1. So let's say let's give it a number 3. And then for n equal 3. And then I will solve. So it's going to be 3 plus 2 factorial divided by 3 factorial. So this is equal to 5 factorial over 3 factorial. What will be our answer? Our answer is 5 factorial over 3 factorial is 5 times 4, right? Okay, so what did we realize here? We got 5 times 4, which is 20. We don't want to simplify it because we want to understand what happened. So we noticed that when we have 3 in here, all right, we get 5 and 4. Let's try another number. Let's try number 4. Let's see what that gives us. 4 plus 2 factorial over 4 factorial. That's n factorial. So it's going to be equal to 4 plus 2, which is 6 factorial, over 4 factorial, which is equal to 6 times 5. What are we noticing? These numbers are always 2 larger than n. So this, the simplification of it is going to be n plus 2 factorial over n factorial is going to be, what is 5 compared to 4? It is n plus 1. What is 4 compared to 3? It is also n plus 1, so that's repeating. Times, what is 6 related to 4? It's n plus 2. What is 5 related to 3? It's n plus 2. So this is what we are getting as an answer. We're getting n plus 1 times n plus 2. All right? This is how you can simplify it. Always just substitute a value for n. Find the relation between the n value and here and see if it's repeating and the other n value and there, and just solve it. Let's take one more example. Let's take part D. All right? 3 n plus 1 factorial over n minus 1 factorial is equal to 126. صح? Yes. So again, let's just substitute a random value for n so we know how we can simplify this. All right? So first, let's just substitute a value for n equal to 3. If we have n equal to 3, we're just going to look at the left side of the equation. We can add 3 into 3 plus 1 factorial over 3 minus 1 factorial. In other words, this is equal to 3 times 3 plus 1 is 4 factorial over 3 minus 1 is 2 factorial. So it's equal to 3 times. I just want to look at the factorials part. What happens? So it's going to be 3 times 4 times 3. All right. This is the factorial part that we want to look at. The 4 times 3. Okay, so for n equal 3, this is what we got. Let's try n equal 4. n 3 into 4 plus 1 factorial over 4 minus 1 factorial. So again, this is going to be equal to, we'll keep the 3 outside, we don't care about it, we're just looking at the factorial. So this is going to be 5 factorial over 4 minus 1 is 3 factorial. This is going to be equal to 3 times, the factorial part is 5 times 4. Again, we found another relation, and now we're going to check. So what is the relation that we are seeing for n, for just this part, for just n plus 1 factorial over n minus 1 factorial? So n plus 1 factorial over n minus 1 factorial. What is the relation we are seeing here? فبنشوف أول واحد, which is 4 times 3. And we notice that this is basically, if we're comparing the 4 to this, it's n plus 1 times n, because n is equal to 3. Let's see if this is correct for the other case as well. This is going to be 3 times 5 times 4. So 5 times 4, 5 is n plus 1, 4 is n. Okay, so it is the same for each case. So we can say that this is going to be equal to n plus 1 times n. And now you can do it with simple algebra. You will just substitute this into this place. So it is going to be 3 into n plus 1 times n. Again, we are just substituting n plus 1 times n instead of n plus 1 factorial over n minus 1 factorial is equal to 126. And now we can solve for n. So 3 into n plus 1 times n is going to be n squared plus n equal to 126. 3n squared plus 3n is equal to 126. This is a quadratic equation. You guys remember this from minus 1 to 6 equals 0. You remember this from math 1. Okay, just use mod 53 on the calculator and you will get your final answer. Remember, just a quick reminder, a equal 3, b equal 3, and c will equal to minus 126. You'll just use mod 53, but this is a, but this is b, but this is c, and we will solve it. All right. Now we are getting into the actual combinations or the actual principles when it comes to counting. So this question says, we have 5 different blazers, then 4 different shirts, 7 different ties, and 9 different pairs of pants. يعني ثياب, then blazers, shirts, ties, and pants are available in a top men uniforms and tailoring. In total, how many different suits consisting of blazer, shirt, tie, and pants are there? يعني كم طريقة نقدر نلبس كل هذيلا ويا بعض? How many different methods, how many different ways do we have of wearing all of these? So the easy way of doing this is, what I still do till today is I put boxes for each one. And then I put a box for each one. So the first box is for blazers. The second box is for shirts. Third box is for ties. And fourth box is for pants. All right. How many blazers do I have? I have 5 different blazers I can choose from. Hello. How many different shirts I have? I have 4 different shirts I can choose from. Nice. How many ties? 7 different ties. How many pants? I have 9 different pants. And all you will do is multiply them with each other. And your answer is going to be equal to 1,260 different suits. يعني different suits or different combinations بما معنى of both. All right? So this is how you get it. When you have options, use your box method. Yeah, I know you could just directly multiply them, but there's a reason I'm using this box method, because I'm going to be using it to solve most of the questions. For blazers, we have this many options, so we can choose from 5 options. So I put all the 5 options here. For shirts, we have 4 options. For ties, we have 7. And for pants, we have 9. And then just multiply all of them, and you will get your answer. Next, a question. There are 9 starting players on a baseball team. And what number of ways can the coach make out the batting order? يعني. And then 9 players. All right. So if I put boxes, we have 9 players. We want to have a specific order for each one. So this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. So we have a specific order. We have a total of 9 players. All right. 9 players. And we want to put them in order for baseball to bat, يعني one by one. دورك بعدين دورك بعدين دورك بعدين دورك. Like that. So the first one, we have 9 choices to choose from to put the first one. From these 9 players, okay, we can choose from 9 players to put in the first box. But as soon as we choose a player, we will remain with 8 players to choose from. So in the second box, we only have 8 players to choose from. خلاص اخترنا اسم الأولي، ما نقدر نمد نختار يكون الثاني. So we have to choose a second one. So we have 8 players for the second one. And we will do the same thing again. Since we chose a player here, we will be left with 7 players for the next one. So we have 7 players we can choose from. For the the third person that will be shooting or batting, we have only 7 players to choose from. And it will keep on going. 6, 5, 4, 3, 2, 1. This is the order we can do. And again, we will just be multiplying everything with each other. Now, what does this show? What is this very similar to? If you notice, 9 times 8 times 7 times 6, this is basically 9 factorial. And that will be your answer. All right? So this is how the factorial is sometimes used in combination and permutation, and the choosing and the order as well. All right. Now, going on to the next question. If you guys have any questions at any point, please type it in the chat and I will stop and address them. Find the number of distinct arrangements of these letters. يعني شو معناته؟ معناته they want us to find a way of ordering these letters specifically. All right. Find a distinct way to arrange these letters. And then إن مثلا الحين, one way of writing this is محرك for the first one. All right. So we have M-U-H-A-R-R-A-Q. Then another way would be, for example, saying M-H-R-U-R-A-A-Q. Then, so using the same letters, we are just rearranging it. So they want to know how many different ways يعني how many distinct arrangements are there فهني we need to go again step by step. All right, so the first thing we're going to do is see how many letters we have. We have the letter M, so we have M. We have the letter U, so we have U. We have the letter A, H, we have H. We have the letter A, we have the letter R. Again, we're not going to look at the repeating ones. The repeating ones we're going to neglect. And then we're going to have Q. All right? This is how you're going to look at it. So how many different letters did we have? We have a total of, so we have these many letters. And what are the repeating ones? How many do we have repeating? We have the letter A that is repeating, and we have the letter R that is repeating. So we have 2 repeating letters. All right? So when we have 2 repeating letters, first off, the first way to do this is, again, the same idea of boxes. I just use boxes to do my explanation, not to actually solve the question. It's just for explanation purposes, so you don't have to do it the same way. It's just to understand. So we have 1, 2, 3, 4, 5, 6, 7, 8 locations in total. So 1, 2, 3, 4, 5, 6, 7, 8. All right? So we have 8 boxes in total. And we have 2 repeating letters. So usually, if we are choosing, we're going to do 8. After we choose a letter, we're left with 7 letters. So we're going to do 7, then we're going to do 6, then we're going to do 5, 4, 3, 2, 1. This is the usual way, or this is also known as 8 factorial. All right? So this would be the answer if we had no repeating letters. So answer if no repeated letters. However, here we do have the letter A being repeated, and we have the letter R being repeated. All right? No. Sorry, my voice is just too much today. No. I want to separately look at each letter. So I'm going to color this with a different color. All right? So, how many times is the letter A repeated? It is repeated 2 times. How many times is the R repeated? It is also repeated 2 times. We're going to look at each letter individually. And then we're going to mention them here. So R or A is 2 factorial. 2 factorial. Why is it 2 factorial? Because it's repeated 2 times. So we're going to put 2 factorial instead. And we have, which letter was it? R. I mixed up the colors. So A is going to be 2 factorial. And then, or before I even put 2 factorial, it's 2 times. And R is 2 times. The total is this. Total is going to be 8 factorial. So the total we're going to put on the top. And at the bottom, depending on how many times it is repeated. So in this case, it's repeated twice. We're going to put 2 factorial for the A and then 2 factorial for the R, because A is repeated 2 times. So we're going to put 2 factorial, and R is repeated 2 times. So we're going to put 2 factorial. All right. So if you notice, this is going to be equal to 8 factorial times, so it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 2 times 1 times 2 times 1. Okay, obviously in the calculator you're not going to write all of this. You can just straightforward just write the factorial directly. Tamam? So if I just do that, 8 factorial divided by 2 factorial times 2 factorial, it is going to be, we have 10,080 combinations for the word محرك. All right? That is how you will do it. Again, just quickly to repeat, we have a total of 8 letters, يعني the total letters which we have are 8. So we're going to have 8 factorial at the top. The repeating letters, so A and R, we're just going to put them under. And how many times are they repeated? they are repeated only 2 times. The letter R over here is repeated how many times? Over here, the A is repeated 2 times, and the R is repeated 2 times. That is why we put 2 factorial at the bottom. Let's look at the word Mississippi. Let's look at the word Mississippi. All right. So the word Mississippi, it has multiple letters that are being repeated and multiple times as well. Then, so let's look at the repeated letters. First, we have the M, it's not repeated. The I is repeated. It's repeated here 1, 2, 3, 4. Then we have the letter S, 1, 2, 3, 4. Then we have the letter P, 1, 2. All right. So if we write that down, I is repeated 4 times. S is repeated 4 times. All right. And P is repeated 2 times. Okay. So this is what we have. Now, again, same exact concept we're going to apply. How many boxes we have? We have how many letters? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in total. So we have 11 boxes, meaning we have 11 factorial at the top. At the bottom, we're going to have 4 factorial for the I's. Then we're going to have 4 factorial for the S. Then we're going to have 2 factorial for the P. We're just going to put that in the calculator and we will get our answer directly. That's it. Very simple. You will count your repeated words, your repeated letters, and then you will see how many times they are repeated. You will mark it down and you will put it in the division. And at the top, you're going to put all your the total locations or the total number of spaces or letters you are using in total. So 11 factorial over 4 factorial times 4 factorial times 2 factorial. 3, 4, 6, 5, 0. All right? 3, 4, 6, 5, 0. Okay? Now, this is for finding out when we have a letter, all right? When we have a letter, when we have a word, how we can have it with repeating letters, how to solve it, all right? It's the same exact idea. Now, going on to the next question, Ali. 34650 in the worksheet, it's how much? No, in the worksheet, okay. I'm doing part B. Part B in the worksheet, let me check. Are you sure? I think you're talking about part C, right? Oh, all right, fine. And by the way, I have checked the worksheet. There are some answers that are unfortunately incorrect. Not just this, also in technical math, it happens sometimes. Just make sure you're understanding the concept, okay? The final answer will come naturally. It's just making sure you know how to solve. That is the most important thing. But thank you for checking and letting me know. Now, Ali has trouble remembering his PIN number. He knows it contains the digits 1, 2, 1, 3, 4, and 6. Okay, but he cannot remember the order. So how many different orders are there without repetition? So this is very important. It says without repetition. All right, so the numbers are not going to be repeating. So you have a PIN code, a 4-digit PIN code. Okay, and you have to choose from these 3 numbers, 4 numbers, 4, 6. All right, he knows that his code has these numbers in it, but he doesn't remember the order of them. So what are we going to do? We're going to choose from these 4 numbers, and he knows none of them are repeating. So we cannot have the code to be like 4, 4, 3, 1, for example. This is not right. We cannot have this because there's nothing repeating. All right? So how many options we have in the first place? How many numbers we have? We have 1, 2, 3, 1, 2, 3, 4 numbers to choose from. So we have 4. Then, how many numbers are left? If we choose, for example, let's say the 1 is gone. How many numbers are left? We have 3. Okay, let's go in the opposite way, actually. It's better that way. So, we chose the 4th number. How many are left? We have 3 numbers left. So 3 numbers left. Again, moving on. We chose 3. Now we chose 2 numbers. How many numbers we have left? We have 2 numbers left. 2 numbers left to choose from. So 2. Again, how many numbers left to choose from? We're going to have only 1 number to choose from. So this is just 4 times 3 times 2 times 1. All right? So the answer is 24. Now, I'm going to add an extra part to this question. All right? What if there can be repetition? So the same numbers, 1, 3, 4, and 6. Okay? This is a separate question. If repetition allowed. Okay? This is if repetition is allowed. What is going to be the case? So again, the same 4 numbers, we're going to choose from them. We have 1, 2, 3, 4. How many numbers can we choose from? We can choose from 4 numbers. Okay, the first one is easy. Because we can have repetition, we do not cancel this anymore. It will stay. Why? Because you can have 2 6s. You can choose the 6 4 times if you want to. Yani, for example, we can have a code that is 6, 6, 6, 6, because we are allowing for repetition. Or we can have it to be 6, 6, 6, 4. It's fine if it has repetition. So we can choose from any of the 4 numbers every single time. So it's going to be 4 times 4 times 4. Or in other words, it's just 4 to the power of 4. All right? So this is going to be equal to 4 to the power of 4, 256. So you can see how many more combinations you can have. You can have 256 combinations compared to the 24, only if you allowed for repetition in your code. This is how usually it's done. Like this is like when you're looking at passwords and pins, they allow for repetition because you'll have a lot of more different ways to access for them. And at the same time, it will allow for more security for the number. All right. Now, let's look at the next question. Find the number of different ways or of arrangements that can be made from the letters, the words formulate and polytechnic. All the vowels occur together and all the vowels do not occur together. Now, here, so let's first look at the word formulate, okay? The word formulate has F, O, R, M, U, L, A, T, and E. I wish I did not make my first boxes too big. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. We have 9 total positions. How many letters we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and none of them are repeating. So all of the letters are unique. All right. So for formulate, for part I, for formulate, F, O, R, M, U, L, A, T, and E. None of them are repeating. They are all unique. All right. So the total number of arrangements will simply be, how many we had here? We had 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 times 8 times 7, yada, yada, yada. It's going to be 9 factorial. However, this isn't what the question is asking. The question is asking if all the vowels occur together, meaning that the vowels here are the letter O, the letter U, the letter A, and the letter E. So we have 4 vowels in total. We have 4 vowels. All right. So 4 of these boxes need to be vowels, and the remaining can be anything. But these 4 boxes, they have to be next to each other all the time. So now what do we have to choose from? We have a total of, what is the remaining number of letters we have? We have 1, 2, 3, 4, and 5, right? Sorry, just 1 second. Sorry, guys, give me 5 minutes. I need to go do something. I'll be back. I'm very sorry about this. 5 minutes and I'll be back. Sorry about that, guys. I'm back. Where were we? What were we talking about? Okay. Again, I apologize. So let me repeat the question from the beginning because I don't know where I reached. So find the number of different ways. Okay. So we're arranging. All right. So all the vowels occur together. So we have the word formulate. We found out the number of vowels that we have. We have 4 vowels. All right. So what is remaining? We have now the number of non-vowel words, non-vowel letters, which is 1, 2, 3, 4, 5. We have 5 non-vowels. And then remember in part A, what are they asking for? That the vowels occur together. So in other words, they want it to look something like this. They want it to be F, R, M, L, T, O, U, A, E, for example. All right, for example. So these should always be grouped as if they are one letter themselves. All right. So this is how we will consider this. We'll consider this as a letter, this as a letter, this as a letter, this as a letter, and then this, all of it as one letter by itself, and then we will analyze it. We know that we have 4 of these that have to be next to each other. And then, so what are we going to do? We're going to reserve 4 spots for the vowels at the very end. We could do it at the beginning as well, but I usually prefer at the end. We're going to reserve these spots for the vowels. And then, Lena, they could be here, they could be in the middle, they could be at the beginning, but just at the very beginning, we're just going to reserve those spots for the vowels. And then we're going to do what we usually do. So we have how many options to choose from for the first one? If we look at this as a whole, and then we have 1, 2, 3, 4, 5, and 6. We have 6 to choose from. So we're going to choose 6 in the first one. Then we're going to remove 1. Then we're going to have 5. Then we're going to remove 1. Then we're going to have 4. Then we're going to remove 1. Then we're going to have 3. Then we're going to remove 1. Then we're going to have 2. Okay? Remember, we have reserved 4 spots for our vowels. All right? So we're going to stop here at 2. All right? Asala, it doesn't matter for the 1 because it's going to be times 1 anyways. And then we have to choose now the order of these vowels themselves. Lihum, O, U, A, and E. And we're going to do the exact same thing again. Okay? So how many letters we have? We have 1, 2, 3, and 4. So the first one we have here is going to be 4. We have 4 options. We're going to cancel the 4. Then we're going to have 3. Cancel the 3. Then we're going to have 2. Cancel the 2. Then we're going to have 1, which is 1. All right. And then we're going to multiply all of this together. Does this make sense what I did here? Again, quick recap. So first, we want to see the condition. The condition is all vowels have to be next to each other. So the vowels, the red, we are going to have to group them together. So that's what I did at the bottom here. And then we'll consider them as one whole piece and reserve a spot for each letter at the end, at the beginning. It doesn't matter. Just reserve a spot for them. So then we can do the analysis of it separately. Then we look at this as a whole. We have 1, 2, 3, 4, 5, 6 total components of it, or letters. So the first letter is going to be 6, then 5, then 4, then 3, then 2. Then we're going to reach the reserved spot for the vowels. Then the vowels will have their own order. So that it can be O at the beginning, it can be O in the middle. So we're going to do the same exact thing again. 4 times 3 times 2 times 1. All right. For part B, they say that all the vowels do not occur. So vowels should not be F, O, R, M, U, L, A, T, E. So they wanted something like this, where the vowels are not next to each other. Remember, we have 9 boxes, right? So if we want to find the total number of combinations, it's just going to be 9 factorial. صح ولا لا? It's going to be 9 factorial. All right? So 9 factorial is equal to, actually, let's calculate this one. I just didn't calculate it yet. So 6 times 5 times 4 times 3 times 2 times 4 times 3 times 2 times 1. All right. It is 7,000. Let's do it in orange. 17,280 for this one. Okay. Let's now find the total number of possible combinations. It is going to be 9 factorial, right? If there's no rules or regulations here, since they are all unique, we're just going to put 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is simply 9 factorial. All right? So let's do that. Let's put 9 factorial in our calculator. 9 factorial is equal to 362,880 combinations. So these are the total number of combinations possible. All right? These are every single possible combination. So how can we find the combinations that are not this, the opposite of this? It's basically we're just going to subtract it from the total number of combinations, because this will be equal to 17,280 combinations of vowels stuck. Is that what they use? The word stuck? Occur together, stuck, whatever, occur. Okay. Plus a specific number that we don't know of vowels not occurring. بالمنطق. All right? Everything that is possible and not everything that is possible with vowels and not possible with vowels should be the number of the total combinations which we found earlier, which is 362,880. So how can we find the vowels not occurring? Simply, we just take this to the other side and subtract. So it's going to be 362,880. 17280 is this, the part A answer, the number of vowels occurring. So all the vowels occur together. The condition where the vowels are occurring next to each other, يعني متصقين في بعض, all right? This is the number of possible combinations. يعني there is 17,280 different ways you can have these vowels ordered next to each other. So how are we going to have them not ordered next to each other? It is going to be the remaining different ways that we have. So we are finding the total possible ways of just ordering this, and then we are removing the number of ways the vowels can occur to find the number of vowels that do not occur. So it's going to be minus 17,280. And this is going to give us the vowels not occurring, which is minus 720, 3, 4, 5, 6, 0, 0. So these are the different possible combinations we can have for part B, where all the vowels do not occur together. All right. So that's basically it. Part B2 is the exact same thing for the word polytechnic. You're going to be applying the exact same concept. The only difference here is going to be that we have the letter C repeating. So we're going to apply the concept of repeating letters for where we divide by 2 factorial for everything. That's it. All right. Yeah, that's pretty much it for this. Let's see the next question. So we can try to finish as much as we can. Salads are Darren's favorite food. In the case, she picks a lettuce type from 3 choices. زين. So عندها lettuce. She has 3 choices. زين. Lettuce. 3 choices. This is this part. 3 choices of lettuce. Then let's see the next part. A vegetable from 6 choices. So vegetable from 6 choices. We have a vegetable that she can choose from 6 choices. And a dressing from 9 choices. So a dressing from 9 choices. So this is the dressing, and we have 9 choices. How many salads she has? Does she have the option of putting together? Very simple. We have 3 different lettuces she can choose from. 6. What was this again? Vegetables she can choose from, and sauces or dressings she can choose from. And then you just multiply them. 3 times 6 times 9 is simply going to be 162. Different choices. All right, very straightforward, very simple, very easy. We did this multiple times already. Now, if a teacher must sit together, okay, this is a good one. If 3 teachers must sit together, All right, so we have 3 teachers must sit together, so they have to be close to each other. And then, so we have teachers here, they have to be close to each other. We have 4 male students must sit together. So we have 4 male students that have to be seated next to each other. Okay? And 6 female students that must sit together. So we have 6 female students that must sit together. All right? So female students, we have 1, 2, 3, 4, 5, 6. And then, so what are the possible seating arrangements for 3 teachers? So now we have 3 teachers, a total of 3. So all the teachers are going to be used. So 3 teachers, 4 male students. So all the 4 male students, and 6 female students, and 6 female students. Okay. So again, this is the same concept as we did earlier. All right. We're going to have to find out how many different ways we can arrange these people. We cannot simply just do 6 times 4 times 3. That is not the way that this works. Or we cannot just do add them all up, which is 6 plus 4 plus 3 is going to be 13. We cannot do 13 factorial, and then that's our answer. It's going to be a huge number, but because we have a specific order we need to choose from. All right? So, before I solve this question, let me talk about the concept of permutations and combinations. This recently, all I'm doing is just using the basic factorial method. But there is something you guys need to know before I start showing you this. Let me teach you what the P and the C stand for in permutation and combinations. So we have 2 things. We have the letter P. We have the letter P, which means permutation. All right. Basically, this means that when you are choosing something, all right, when you're choosing something, the order is important of how you're choosing. So order matters. All right. And the calculator, you can find this as, I believe, NPR. Yes, as NPR, this button, which is right under your delete button. All right. How do we use this though? All right. How do we use this? Let's start with a very simple example. Let me think of something off the top of my head. You have 2 seats, okay? In class, you're going to class. You have 2 seats. You have seat 1 and seat 2. Zain? And you and 3 of your friends are going together to class. Only 2 of you can sit in here, all right? Only 2 of you can sit in here. Not all 3, unfortunately. You have 3 friends, so the total are 3 friends. And you have 2 seats. You have the first seat and you have the second seat. Then only 2 of you. Let's give these guys the names. Let's call the first one person A, person B, and person C, just to be simple. So there are 3 friends that can sit here. The first way they can sit is A and B. This is the first way. The second way is going to be B. A and B is the first one. The second one, for example, B and C can be sitting next to each other. All right? Here, like I said, when we're talking about permutation, the order of these friends matter. Yani if A is sitting in the red chair and B sitting in the purple chair, that matters. That is important. So there is another option as well, where B is sitting in the red chair and A is sitting in the purple chair. This is what they mean by order matters. معناته we cannot just select A and B and هل صديقين بس راحوا قعدوا ويا بعض. No, we cannot just say those 2 friends are sitting next to each other. No, we are saying friend A is sitting in this place and friend B is sitting in that place. This is when order matters. All right? So what other options do we have? We have also C and B, and then we have A and C, and then we have C and A. All right? So if you notice how many total options we have 1, 2, 3, 4, 5, and 6. We have a total of 6. So if we do the n PR, we are going to get 6. But we did not talk about the important things, which is what is N and what is R. Then, first of all, N has to always be the larger number between N and R. All right. N is basically the choices you have. So you have the 3 friends. In this case, this is the 3 friends. So N is equal to 3. All right. For R, this R is how many available options you have, or how many choices you have to fill or select, or the candidates, or whatever it is. So in this case, what is the options we have? We have 2 tables. 2 tables. So in this case, it's going to be R is equal to 2. All right. So N is equal to 3 and R is equal to 2, which is 2 tables. 2 tables or 2 chairs that are available. All right. So if you go to your calculator now and you do 3 shift P2, you're going to find out that the answer is going to be 6. Okay. This is how you can use permutation. So permutation is just a method, a way of choosing where the order matters. This is very important, where order matters. All right. Now, again, the same concept can be used again, where 3 friends, let's say now the order does not matter. So this is where we will use something called C, which is combination. In this case, order does not matter. This is the main difference between P and C. Yani, if we're talking about the same 3 friends, if we have our red and purple chair, if we have friend A sitting here and B sitting here, that's it. This is our first option. We don't care if it's B sitting here or A sitting here. We don't care about that. All of this is one option. This is one combination of the chances. So if we see, we have A, B, or BA, this is our first one. And then the second one is going to be BA, BC, or CB. It doesn't matter. These are the same option because we don't care about the ordering, who sits in which chair. Okay. This is the same option. Okay, so B and C or C and B, because they are the same letters. It doesn't matter where their location is. And the last 2 letters is going to be A and C. All right. A and C. Keep in mind, the N and the R are the same. So N does not change. N is equal to the 3 friends. And the R is equal to the options we have, which is 2 options. We can have them either sitting in 2 chairs, basically. All right. So here, this is where we're going to have 3CR, and it's going to be equal to, or 3C2. And this is going to be equal to basically 6, sorry, not 6, 3. We have only 3 options. See, we have 1, 2, and 3 options that will happen. So this is basically how you will be using the permutation and how you'll be using the combination, depending on whether or not the order matters or if the order is not important. All right. صوتي بدأ يروح. Let's take just a 3-minute break. And we will continue. Just a 3-minute break until I can catch my voice a little bit. And then we will continue with permutation and combination. And I will show you how we can use it in solving as well. All right. So just a 3-minute break and then we will continue.